I've started the stream.
Wait, am I supposed to leave at 3:30?
Oh, you told me.
Wait, I'm an idiot. What the hell, man? They're literally 11 o'clock. None of these can be. Okay. Delete all of this shit. Okay, that's a really weak battle. Sorry. Okay.
Which question are you doing?
F3. So now I just need to make this into a. Oh, wait. I don't even know if it works. I don't know if it works. Okay. Let's act like but then we can divide by potentially equal to.
I joined the stream, people.
Someone's laughing. It's your one useful thing.
What do you mean one useful thing to even feel?
The one useful thing you're able to do.
That's not very nice, Liam. Yeah, throwing my laptop dice so far.
Yeah. Okay, that's still. I don't know, that's kind of weird. Work this out. Like either that or the rest of the like just over alone. For example, maybe something like 2n plus 22, 12, so something like n equals 6. I'm like n equals 6. But, it's like two consecutive ones.
N has to be odd, right?
N has to. Yeah. Yeah.
So you need n minus 1 to be a square.
N minus 1 to be square, right?
Because you can factor out the 2, right?
Factor out the 2, then you get 2n minus.
Oh wait, 2n minus 1.
Sorry. Wait, no, what?
Yeah.
Oh yeah, wait, yeah, okay, that makes sense.
Wait, you talking about the second one?
It's not like
Two consecutive. Yeah, there's literally no way that works. There's just no way. Not possible. Not possible. Okay, I think that works, right? So then, so now.
It's not a square number.
Wait, is it? Yeah.
Yeah, it is.
Yeah, because they're literally adjacent, so. Yeah, okay. That works. Okay, and now I just need to check this case.
What?
So past what point are they? Okay, let me write down a bunch of squares. Squares. 1, 4,
What?
You solve N2?
That's in what?
Okay, so it's,
Yeah, I guess I'll keep trying.
so it's like 3. Okay,
Wait,
so
does anyone solve N2?
What about to 19?
I think
Are you working on N3?
Six.
Have you guys solved N2?
Yes.
oh wait, alright, that's like literally the only. If 1 equals like it, then. Wait, what did I do? What did I do? Oh, wait. So, okay, so I was saying like, has to be like 5 squared. Oh, 3. Wait, hold on, no, that's a little bit. That's still low. Okay, I'll still need to check more cases, that means. But once that's done, I should be fine. Wait, hold on. No. Stop. Like, that bounds it, but.
So what's the statement for N2? It's like out of, if you have all those numbers in that set, there's got to be a number that divides all of them,
Yeah.
and it's the biggest one. So the number can't be that big then.
It has to be smaller than the smallest non-zero. So,
Yeah. So this question should be easy, right? I don't know how yes Liam really applies here, but maybe. Gustavo, have you done N2?
Like, under the line, yeah.
Okay, well maybe you can present the solution at some point. When
N3
you're ready.
sounds pretty interesting. Yeah, like this is a gap too. It's like,
You should figure it out yourself, man.
let me try to figure this out.
Like, first of all, do you understand what the question's asking? Do you understand what the question's asking? Are you sure?
Oh, wait,
This would be a good time to ask.
Two times 13 plus 10 equals 30. Okay, I think I do. I think. Wait, no, I forgot about the negative. Whoops, I need to case back to the negative still. Oh wait, no, it's still the same thing basically. It's very similar. Wait, like once I turn it into this form, it's like basically the same thing. Just flipped, kind of. Am I right? Anyway. Oh yeah. Yeah, but I still need to check the bunch of negative cases that I want. Okay, but that's already over 26. Like, that's 26 already. Wait, no, that's stupid. No, that's not, I made false claims. It's false. Untrue. I want 2n plus 10. So that should be like, at least what? Like, 11? Okay. Should be at least 10. So that's supposed to equal like 5. Minus 5 to n equals. Okay, so like, that's. That's not what I was looking for. Like, I want to do a case where, like, the bottom guy. Alright. Okay, so here I want n minus 6. Minus 6, 2n. That's minus 2 on the bottom. Still more case bashing to be done. More cases that I have to check. Minus 12. Right. Right. Am I right? 26. Okay. I'm not even. I can't even do. Oops. Can't even do. 7 minus. Oh god, this is gonna take a while, isn't it? Yeah, this is gonna take a while. Oh god.
Wait, N3?
The temptation to have a computer do it for me.
Oh.
Bro. Isn't this like the same? It's literally the same thing as
You're literally skin cancer, boy. You have a giant lump in your forehead, which appeared in somewhere between the last year and somewhere before the last 3 months, but earlier than a year ago. It just grew out of nowhere.
This is the odd cases.
Uh-huh.
Right, that's like not the same thing.
That very much
So I
sounds
actually
like
haven't
skin
checked
cancer.
these cases.
Why? Why skin cancer?
A lump on your skin grows from non-existent to that in less than a year.
Aren't all lumps on your skin? I don't know, like, where else can lumps go?
So
You were like,
213, 415.
Do you have lumps that have grown to that size in a short period of time?
Short period of time, so 6 months is a short period of time.
I feel like if you eat some, like, oily stuff, you get, like, these kind of, I don't know, what do you call them?
Pimples are not that. That is not a pimple.
Are you accusing him of skin cancer?
Yes!
Using him.
Average weed.
10, 1 and 1, 12. So I just need to get up to like 25 as well for this. Except I need to get up to like 20.
09.
12, 23, 13, 25, 4. No, wait, no, what am I doing? No, 14, 25, 16, 27. That doesn't work. 27 is a cube. 17, 18, 29, 20, 31, 22, 33. That's 3 over 2, so that means that's alright. 24, 35, 26, 26, 13. Yeah, so this is the point at which you can't say that there's literally no possible way. Okay, I think that's probably done. Too many cases to check. Maybe there's a better way that you do it without checking so many.
900,000 dollars.
Wait, Slava, we're kind of waiting for you for N2.
Oh yeah.
So are you trying to do it, or what are you doing?
Well, I'm doing N3
Or did you do N2?
a long time ago.
Do you understand the solution?
I have makes sense.
Yeah, I guess that solution. So good. Alright. Damn, N3 actually isn't trivial. That's crazy. Mm. Oh, Liam has realized. He had realization. So basically, just yeah. Damn, bro, that was crazy. That was crazy. Mm. Yeah, I guess I still have to like work out this. Like right. Probably that's like not really out of. Yeah, I need to prove it though. Rigorous. Two is just like seeing glitches. Hmm. Yeah. Hmm. Yeah, so that case, I missed that case. It actually might have costed, but it does not. Yeah, like they're literally curve crimes, so you cannot cancel. That's why. Yeah, and then they're too close to each other to do anything. Okay.
What?
What's
The
that?
paper fell on the floor. Really? The paper just there fell on the floor. Did you throw it?
Yeah.
I don't think then it didn't fall.
What is on here? I don't know. It's literally just like. One. Oh yeah, I need to prove this claim as well. This claim is like sus. Okay, it's not that sus. Who knew that juniors would have to do this?
Hmm.
That's crazy. Okay, well, I mean, it's not bad. Oh. Hmm. Hmm. Why is this? I can do here. That's just one important spot. Can also be here. So, and then I eliminate those two. Uh, farm wash house. Bro. Nearby where the farm wash house. Thanks.
How many tabs you gonna open?
I don't think it really? So you need more space now.
Yeah,
I don't have more space.
it makes it.
Yo, it was March 16th.
10 seconds.
Oh yeah. Wait, Michael, when you told them to go to the other room if they wanted the game, did you expect them to actually go into the other room and game?
Well, I mean, they are like staying beyond their lesson, I guess.
So they're like, gonna do whatever they want. So, how can a year 9 and a year 8 game so easily with a year 4?
I don't know. I feel like you're kind of worrying a little bit beyond your jurisdiction. Because I'm currently gaming with the year 4. Okay.
Yeah, but you're the
Oh.
year 4's dad.
Pro box roots. Literally AAA gamer.
No.
Oh, I'll join you on a bunch of tabs, sir.
Oh, nice.
I do not have this level.
Alright, so Slava, when are you gonna come up and present this problem? Hmm? Are you ready?
I'm just back from the
Alright, just give me a sec.
David's online.
Is minus 13 also a solution?
Minus 13. Or, but shouldn't be. Minus. What?
Alright, so explain what the problem is, okay? And then tell us how to solve it.
Nah.
Alright?
So we need to
Wait,
find
you gotta wait.
Recording in progress.
There you go.
Why don't you go?
You got the hot seat.
I'll be joining you on all the tabs. Good mind. Have you started a stream?
Yeah.
Interesting.
There's only one person in the live chat for some reason.
So the problem is to find the greatest divisor of the even numbers of n to the power of 4 minus 4n squared. So first, n has to be even because it says that in the problem.
You can write it down, John.
Okay, which means that n can be rewritten as 2m.
Whoa.
So then, n
What's
to
M? Do you really need to turn to him for that?
it's like half of n.
M is a positive integer. Okay?
Okay.
It can be any positive.
Okay, so then this thing can be rewritten as 16 m to the power of 4 minus 16 squared, which is 4m squared minus 4n and 4m squared plus 4. So
So yeah, that can be rewritten as 16.
Did you do that factorization or did he do it? I mean, it's not the most natural factorization. You see one that's more natural?
Oh.
You can directly
What is the most natural factorization? Yes.
Wait, would we just factorizing the 16 first?
Yeah, the 16m squared first.
Okay.
Wow.
So then, if m is an odd number, then both of these expressions are even, because odd number minus odd number is even.
Mm-hmm.
And if m is even, then both those expressions are also even.
Okay.
So that means that both of these expressions can be rewritten as 2x and 2y. So meaning that this can be rewritten as 64xy.
Okay.
Okay, yep. Then, if
Who's test X?
n is
Oh, that's right.
1 mod 3, then 1
What
minus
do you think it's 192 for the
4.
first one?
and 2.
Really?
Yeah.
What's
Then
the smallest even number?
is
What's the
0 mod
It's 2,
3.
sir.
No, it isn't. No, even no
And then
smallest.
if n is
Wait, have you subbed n equals 4 at any point?
N
Then-
equals 4. Let me see.
Like,
What
did
happens
you
when
sub n equals 4 at the start of the problem at all when you did it?
Yeah.
What happens when N equals 4?
Huh?
Yeah,
What'd you get?
192.
Oh, okay. And then it's more
Lava
promising.
sounds so dead last week. It's like, and
I am very dead.
I think you could be more supportive, dude.
excellent job, Slava.
Then
Might express in
16
your voice a bit more.
minus 16 is 0 mod 3.
Doing an excellent job, Slava.
What?
It's invincible.
And if n is 0 mod 3, then it's 0 mod 3. And that means that it's divisible by 3. And 64 times 3
What did I do?
is 192. Yeah, and basically, the lowest number
It
that it
sounds
works
like
is
it might
because
be your strength.
if n is 2, then the answer is 0, which isn't an even number. So then the next thing we variable for n we can do is n is 4, which gives the answer as 192, which is the greatest common divisor.
Okay, so can you summarize what you proved?
Well, that the greatest common divisor is 192.
Okay, so that should have been the very first thing you said, okay?
Oh, okay.
So I asked you for the greatest common divisor, then you state, I think the greatest common divisor is 192, and then you go and prove it, alright?
Okay.
So how does n equals 4 being 192 contribute to your proof?
Because it's the, like, lowest number.
Because it's like the lowest number.
Like, it's the smallest number that works.
Yeah.
But what's it got to do with n equals 4? Does that help? Okay, how do you know that there's not a bigger number that divides all it? How do you know it's the greatest? You proved it's a common divisor, yeah? How do you know it's the greatest common divisor?
Because, like, 192, like, can't be divided by, like, something bigger than itself. To be an integer.
Yeah, so the n equals 4, it is 192. So the greatest divisor of that is 192.
Yeah.
So the greatest common divisor has to be at most 192. Okay, and then how did you prove that it was divisible by every other one was divisible by 192? Can you give us a rough summary?
Because this whole thing proves that it's divisible by 64,
Okay, yes.
and this proves that it's divisible by 3. And 64 times 3 is 192.
Okay, good. So 64 and 3 are like co-prime, right? So
Yeah.
this is by 64 and 3, this is by the product of 64 and 3. Okay, can you remind me how you showed it was divisible by 3 again?
Like mod. Because if n is 1 mod 3, then 1 minus 4 mod is 0 mod 3. And if n is 2 mod 3,
Yeah, but how's 1 minus 4 relevant to us?
because it's like,
It's n to the power of 4.
you get n to the power of 4 and minus 4 n squared.
Okay, so you're going back, you're forgetting about the m's all over again.
Yeah.
Alright, so like, it's kind of going to be like this. So it's like, I claim it's 192, yeah? Here's my proof, yeah? I first claim everything is divisible by, you probably should have just said it's at most 192 because 4 is 192, yeah? That would have been a good place to start. Because usually that's where you would start in the problem anyway, okay? Next step, you would be like, I claim it's divisible by 64, yeah? Then you whip out the m's, right? Okay, so that's one claim, one proof, and then it's finished, right? Then you go, I claim it's divisible by 3, and then you can go back to the n's. See, then it's naturally like discontinued from the m's, you understand?
Yeah, okay.
So here we're thinking about m's and stuff, and then you just go back to 1 minus 4. It doesn't make sense. Okay?
Mm-hmm.
So we're thinking about the expressions with the m's and stuff, and then you're back to n to the 4 minus 4 n squared. Yeah? Okay. Okay, keep going. So if n is 1 mod 4, then that expression is 0 mod 3, right?
Yeah.
What, and if n equals 2 mod 3, then we'll have it.
Well, then it's 16 minus 16, and that's also 0 mod 3.
16 minus 16. Oh, you went all the way up to 16, okay. Yeah, okay. And then, you didn't say, did you say anything when n is 0 mod 3?
Yeah, well then if it's 0 mod 3, then it's 0 mod 3.
Then, well, I mean, sure, but 0 minus 0.
Yeah.
Okay. Anything else?
And
Alright guys, what do you think?
It's good.
Yeah, good stuff. Alright, we'll try it without assistance next time, okay?
Just read my entire book.
It was already better than being explanation.
It wasn't meant to be.
what is doing this? I'm trying
Oh my god.
to fail from it. Rick failed the capture. He failed the
How am I
capture.
failing it?
Recording stopped.
stopped.
How did you fail the capture, bro?
Alright, Alana, have you done N3?
No.
Come on.
Will you do N3?
What the hell?
I'm struggling from N3 a lot. It's so hard.
He failed another one.
To do
It's making me do. Wait, oh, that's gonna hit the button.
Bro,
Why is it making me do a bajillion captures?
what's a capture? Nah.
Wait, no, motorcycle.
Oh,
I'm
yes,
not really good at that.
Figured it out.
Bro, it's literally a bot.
That's what you failing, Liam.
Actual end.
Wait, so, Alan,
There's nothing
can you, do you think you'll be able to present N3
No.
That's
if
correct.
we give you
right?
more time?
I don't know how to do N3.
The guy's not a motorcycle.
Yeah, and you selected him.
Well, can you pick a time to give up, and then we'll have Liam or Alex present N3?
Okay, Liam,
Pick it
you
up.
present N3 for us.
Are you giving up now?
What?
You give up as soon as you're given the option to give up?
Give
That's
up
kind of
immediately.
pathetic.
Bro, he got blocks from the capture.
What
He can't do
What are you
the capture.
doing?
I'm
I'm trying to capture, but it blocks him from the capture because he got
What's
it
a
wrong too many
capture?
times.
You know
I'm like
those.
proving you're not a bot.
Oh.
And he failed so many times. It said
That's too much of
stop
a
it.
bot.
Wait, so the bots are meant to fail and the humans are meant to succeed?
Yeah.
But then he
Oh, I
failed
thought-
so many
Liam's too much of a bot.
Like he failed so many times.
Numbers
Even
were-
I've never been blocked by the capture. Really. Ow.
Bro.
Well, since Lava read my one for N2, I'll read Liam's proof for N3. If I can even read it.
Achievements on
That might be a little.
Actually, so if that was actually Alon's proof, you meant to actually say it was Alon's proof, you understand? You can't
What?
present it as your own. You understand?
Yeah,
That's
but we're
called
communists, so
that's
it
called
doesn't
plagiarism.
Ow.
That's called plagiarism. Okay?
Ow, proof.
Plagiarism is very bad.
It's
Okay.
No, but we worked on it together.
We did.
With me carrying most of it.
Yeah, so and you didn't get mentioned at all, okay?
Communism thing doesn't sound so bad.
Just lava.
If it's lava. Literally just
For
getting all
all
the
of us.
benefits.
For all of us.
All of Slava.
What did you gain from this?
What do you mean?
You lost.
I
Your
gave
work.
3 Botox.
This is like kind of like buying a friend. That's what this
Oh,
arrangement
yeah.
is like.
No. That's river luck.
It makes sense that the test XO1 kid is better at algebra and geo.
Slava did the things.
No, hear me out, because he grinds a lot, right? There's lots of problems.
Slava, you fake Slava.
I don't know. I don't necessarily think so.
He sounds like he does.
Yeah, because you got one of
And
the
geo and algebra, I think, are the easiest to improve quickly at by doing lots of stuff. Because geo, you learn a bunch of theorems, do some problems.
It's actually really hard at his age to be good at algebra and geo. They're like the more. They're like kind of more age dependent.
I feel like what do you mean by age dependent?
Like, kind of like you'd benefit from more experience and abstraction. Combi and number theory are the ones that you can kind of just get into at the start, right?
So that's very strange. Because I actually sucked at number theory at a certain point.
And I followed that pattern exactly. Good at combi and number theory and suck at algebra.
transaction office.
Yeah, like I was only good at combi and geo, which is like kind of weird.
Alright, Alon, what is your plan? Do you have a plan for N3?
No, I'm very stuck in it. And
Like I could solve ASC Q3 geo, but I
Slava,
couldn't
help me
solve
solve N3.
Q2
Negative
algebra.
numbers. Just do the negative numbers. Hopefully we can somehow fake solve it.
Oh wait, do you want to set a time to give up then? How long have you been working on it?
Yeah, let's do 10 minutes.
10
10
minutes.
minutes.
Alright, 10 minutes and Liam presents, okay?
That's kind of a small time frame.
Yeah.
So don't take too long.
We gave up on a
Have you done it, Liam?
10 minutes that I wouldn't.
Basically, but like, I don't
Oh,
know.
basically. Oh,
Basic.
this is setting us off for it.
So someone else can present.
What?
You present.
I don't want to present.
So you're false claiming that you've solved it. That's
When
kind
did I say I solved then 3? I said I solved then 2.
okay.
Yeah, but you were
Now
the one
retracting
who
false
told us,
claim.
Liam.
Definitely.
You
I
thought-
didn't
you thought
retract
it was like
false claims
32
that
at the start or whatever.
Your first attraction being on 16.
Liam, you thought it was 16 at the start. Really correct. But I've never seen one.
Bro.
They didn't get my souls.
Well, I've solved then 3, but I don't want to present it.
Oh, can I see
What? How have you solved this?
Can I see your submission video? You think so?
No.
What kind of
You don't write
solution
it down.
would you not want to visit?
I don't want to get told I'm terrible at explaining things for like the 400,000th time.
Yeah, but
Well, at
you
least you got
don't
the
do it
answer,
anymore.
right?
It's just, but Alex, it's just 13, right?
Probably.
13 silver.
Okay.
Oh no, they haven't tried the small cases.
Wait, 13 or
Maybe
negative
solve
13?
that.
13 or negative 13.
I swear, I don't get it. I sleep and then I wake up and then I'm tired.
You sleep and then
And I didn't wake up with an alarm or anything. But I'm still tired.
Oh, that's just
I
Makes
mean,
limited.
the thing is, like, if you get used to waking up at a certain time, you'll still wake up even though you feel
Maybe it's daylight savings that's causing it.
Oh
like-
yeah, I guess daylight saving time.
Which number is this a figure? You need 9. I don't know.
Oh no.
How did you get 9?
It did some
What's
magic.
Yeah, this is so sweet.
I got 9.
Oh no.
Oh, this is making 9.
Oh, I think. I'm just gonna say that thing.
Oh, I'm just bad at that.
Oh, so
Doesn't even so bad.
Liam is negative 13.
No.
Is it positive 13?
Yes.
How?
Okay.
Try it.
I literally did and it doesn't even work.
What do you mean?
What? You can't do the arithmetic.
This kid.
Oh no, you tried it, I did it.
Oh, I
It's literally in your paper. I didn't even do it.
Also, Alan, your communism strategy does not work in Olympiad very well. You can't bring Slava in and act like you're one person.
Yeah, you can.
Yeah, we can.
See, because both of us are malnutrition, we can just pretend to be one. Alarm sits on my shoulders and we just walk in and pretend we're like tall like Liam.
Yeah, you know, if we come
Alright, fine, I can present N3 if you
if
want.
we come in, Liam's probably still heavier than both of us combined.
Like my brains. Probably.
Yeah. And that's not an insult to you. It might be saying you're heavy, but it might be saying you're light.
You're lying. That is a fact.
Yeah, but you're heavy.
Alan, you weigh 35 kilos.
Bro, how is 50 over 18?
Divided by 2.
What was it?
What? Huh?
It's a common factor.
Oh, wait, divided by 2, yeah.
You don't need a calculator to calculate what 50 over
It's
18.
45 over 9.
Exactly. What does this kid? Do you know what the problem is?
Oh, and you square root.
Oh, bro, what's going on here?
These kids. You're making me suffer mental pain.
Yes. See, I literally told you. What if the manager gonna manage it? So it's only someone jumping in.
Right, you want to present?
Yeah.
Fine.
Fine. I don't know if that's the kind of attitude I want.
Wait, Liam, do you think that it's like nothing else?
Right, you guys want to hear Alex present?
I want to hear Liam present. Because it's funny.
It's funny.
More comedic value.
But then if Liam fails to present like a good solution, then we take this to Alex.
No, I'm always annoyed when Liam presents a students he claims to have solved it, because most of the time it's not
Yeah, that's
solved.
scary.
Yeah,
I
I'll
was
Yeah, exactly.
It's a little bit scary.
Alright, Alex, it's on you now.
Okay, well, hopefully the same thing don't happen with me.
Alright, let me just
Well,
Yeah, maybe we should see.
what did I do? I forgot. Okay, whatever. I just
Hello, Liam.
Are you ready?
Okay.
Click that top button. Start recording and then start now.
Recording in progress.
Okay.
Alright, so what's the problem?
The problem. Find all
Hold on. She literally
And-
done this.
that is integer, where 4n minus 2 divided by n plus 5 is square of a rational number. Okay. So, firstly, let's figure out what happens with the square of a rational number. Right, so we have the rational number, p over q. Okay, they say pq coprime. Is it clear that if you square it, you get p squared over q squared? P squared is also coprime of q squared. So basically, if you take a fraction, which is this, I guess this fraction up here, and then you, I guess, try and cancel it so that it's in this most reduced form. So like basically all the prime factors you get rid of until they're coprime. Then, and if it's a square of a rational number, then the top and the bottom should also be square numbers. So I guess that's cool. I guess the tricky part of this problem is oh no, we can't really treat it like 4n minus 2 is square, and then n plus 5 is also square, because what if they cancel to become square, but they're not already squares? So I did this. So I think I went like, instead of I did 4n minus 2 on n plus 5 is square of rational. If and only if the 4n minus 2 over 4n plus 20 is square of rational. So I kind of just divided by 4. Right.
Times by 4. Or
Divide by
times the denominator.
Times the denominator by 4, right? So why is this? It's because if you just have this as like, if this was equal to p over q squared, this would just be p over 2q squared. And likewise, I guess, if this was p over q squared, then this is just 2p over q squared. I don't know. Just makes sense. So they are equivalent. So now I just like try to find stuff where like this is square of a rational number. Okay, so now I cancel because cancel. Wait, no. 2n plus 10. Okay. So why did I do that? It's because before we had like the 4n and the n. But now we have both 2n. And I like it. Why? Because the 2n, that means that they're like a certain distance apart from each other. So that's a good thing. Because I guess I tried to get something where like the squares, how do I explain this? So yeah, because squares are always a certain distance apart. So if I make the n really large, the squares can't possibly be like really close together. But obviously we still have to deal with what if this cancels down, right? That's bad. Then we can't necessarily make that argument. Okay, so let's see 2n minus 1, 2n plus 10. They are 11 apart. Right. They are 11 apart. So what does this mean for how much we can cancel? So because they are 11 apart, let's check the prime divisors. So that means both of them cannot be divisible by 2 because one is odd and one is even. Both of them also cannot be divisible by 3 because they're different mod 3. Same goes for 5 and 7 because so since 11 is prime, having them 11 apart makes it impossible for them to be both divisible by 2, 3, 5, or 7. It can only be both divisible by 11. Okay, so let's say that they are both divisible by 11. Right. So what happens? Well, because they are 11 apart, they're actually adjacent numbers that are divisible. They're actually adjacent multiples of 11. So now when you do if they're consecutive multiples of 11, we can kind of just write it as say m plus 1 over m, something like that. Wait, actually, no, it's not m plus 1 over m, it's m over m plus 1. Okay, so now we know it's definitely in its, okay, so this is if divisible by 11, div by 11, m over m plus 1, they're clearly co-prime, right? So I guess now we need to figure out, can this be the square of a rational number? Well, for the most part, no. So if we try to do something like, okay, let's just check the low cases. So if m equals 0, this is m, then we get 0 over 1. So that actually works. But I'll get to that in a minute. M equals 1, we get like 1 over 2, and it's like minus 1 over 0. That's not legit. Minus 2 over minus 1. Okay, so yeah, okay, so I can, for the negative cases, I'll just like get rid of that.
This guy's explaining a problem to you that you can't solve, but he can solve easily. Instead of listening, you decide to have a lightsaber fight with your pens.
Okay.
Will you ever evolve beyond two cells?
So remember how I said they were co-prime, right? So this is already in the most reduced form of the fraction. That means that both of these numbers have to be square numbers. However, because they are 1 apart, if you go beyond 1, all square numbers beyond 1 have to be like at least 3 apart, because it's like 0, 1, 4, 9. So the gaps should be like 1, 3, 5, 7. So
he's explaining all the details for you.
So it's not possible for these guys to be square numbers, except for this one, of course, because we have the 0, 1 gap. And then as for these guys, so like anything beyond here is going to be greater. It's too big to have this 1 gap. Anything here, so on the negatives, obviously I have to make it in the most reduced form, I actually have to get rid of the negative. But the same thing happens here. 1, 2, etc. Everything's greater than 1, so I cannot have the gap of 1. So now, yeah, so this is the only case where it's a square of a rational number, which is 0. But that cannot happen. This is 0, but the top is 2n.
Yeah.
Wait, it's kind of sus.
Yeah, like
2n minus 1. So if you so it's like, I suppose it's odd. And odd multiple of 11 has to be, if you divide it, it has to also be odd. Odd divided by odd. It's like, yeah.
Did you get that? What?
Bro.
Are you joking?
I got it.
Oh,
I got it.
Oh,
But I did something different to you.
I thought you said like even like solving.
I don't know, this is just how I
Do you understand what he's saying?
Yes.
There's something different.
Yeah, like I wouldn't ask if you solved it because I know you didn't solve it, okay?
Yeah, okay, so yeah, that's why if they are divisible by 11, then it's not going to work. And we also know that they can't be both divisible by anything else. So now we just want 2n minus 1 and 2n plus 10 to both be square. Because now we just assume it's co-prime. This is co-prime. Alright.
Do you understand what he's saying? You both finish off the proof by now, right?
So how do we get this? So as I said originally, the reason I wanted to get in this form is because they have a constant gap of 11, which means that if I make the 2n big enough, then there's no way both of them are going to be a square number. So now all that's left to do is to check all the cases, which is going to take a very long time, but whatever. Let's do it.
Wait, not that long.
It takes a while. So actually, you know what? Let's write out the prime not the prime, square numbers and see like where the gap is like becomes greater than 11. So it's like 9.
Just the gaps are just the odd numbers. So.
So you can see this gap is now 11. And then anything beyond, that's gonna be, this is 13, this is 15. So we just need to check up until the case where I guess the lower number is like greater than or equal to 25. Because if it's greater than or equal to 25, then we're done. So yeah, then I just bashed all the cases. But we do have to be mindful, right?
Yeah,
so
what
first,
are the cases, Slava? Come on, what kind of cases?
So it's actually not that obvious what the cases.
Like, is it 25 and 36? Do they have to be 25 and 36? Why? Alright, keep going, Alex.
Okay, so yeah, so we actually have to be careful. So what we're actually looking at here is we want both of these numbers to be greater than 25, or like, I guess not exactly. In the negative case, we want the negatives of them to be greater than 25. So we want both of them to be greater, and then beyond that point, we stop. But remember, these are 2n minus 1, 2n plus 10, so they're not actually n itself. So, yeah. So you still have to care about, like, what is 2n minus 1, 2n plus 10. So, let me just get my piece of paper.
So Slava, are 25 and 36 the only squares which are 11 apart? Why are you waiting? You're just guessing an answer and hoping it's right.
Are they the only squares that are 11 apart?
I asked it Slava.
I'm not sure if it is. I guess I just bashed all of the cases for it, but like, just to make sure. So
I feel like Slava might have missed the possibility of having like non-consecutive squares, where it's
2n minus
3
1
plus 5 or something. Plus 3 plus 7.
So minus 1 over 10, this would be like, because they just increase by 2 each time, I think. 1 on 12, 2 on 14, that's 1 on 7.
You know what I mean? Like, they don't have to be consecutive. But obviously, I don't think.
Wait, no. Okay, whoops. I made a blunder. Wait, no, it's. Whoops.
Different.
Yeah.
Are you sure it's different?
Yes. It's completely different.
Completely different.
Yeah. Instead of looking at like, you know how he looks at like the n and then tries to derive the squares from there. I look at the squares and derive the n and get the n.
What did I do? Let me see. So I think I have to get up pretty far before I. That's hard.
Because you can basically find a formula for n from the squares. But instead of looking at like each of the n's,
Okay, I'll just keep writing.
And show you that.
Are you saying the squares have to be 25 and 36?
No. Wait. 25 and 36.
Yeah, I did a transformation, so it's not.
Oh yeah.
It's not the same as the original.
It's not the.
It's like half of it.
Yeah. Wait. No, 25.
25 on 36. Original was like 50 or something.
It will give you the same n, right?
Yeah.
Yeah, it's if and only if, so it's like.
It's 13.
Yeah, I'll just keep writing
Because
these
I treat
cases.
like the n on the top and the n on the second like different variables. Look at like how squares create.
Wait, can you explain why we're doing all of these cases?
Yeah, I just need to check. Basically, what I wanted, I just check up until both of these are greater than 25.
I think my method avoids a lot of
So
Both of the numerator and denominator.
yeah, so if they're both greater than 25, then there's no way they're both squares.
Oh, okay. That's not that many cases, I guess.
Oh wow, look, 25, 36. That is square. So that's 8, 9, 10, 11, 12, 13. That's 13. So beyond this point, we do not need to check because they will be both greater than 25. And yeah. Now,
so easily distracted. It's ridiculous.
Now we can just go to the negatives. Which, yeah, let's go to the negatives.
Right?
Oh god, that's a lot of cases. Yeah, but
But you're not even paying attention in the first place.
Okay, actually, we can basically skip everything where the numerator is like negative and the denominator is positive, because that's goofy. That's not square. That's negative. So what did I start with? Instead, I started with like when it
Consider the negative
was.
numbers.
Negative numbers is basically it's the same as considering 4n plus 2 on n minus 5. What? Yeah, because suppose both n's are negative. Obviously, you can't have. They both have. Obviously, when you take it to the simplest form, both of the top and bottom have to be positive, right? So.
So top and bottom both have to be positive.
Yeah.
Yeah.
So I'll just
Square of a
remove both of
rational
these
number.
minus signs.
Yeah, but the negative signs are cancelled.
Exactly. Once you cancel the negative signs,
It becomes a different problem.
it becomes 4n plus 2 on n minus 5.
So yeah. Anyways, I'm just gonna keep checking because this is like literally what I did.
It was so easy to I walk over here and you start going,
Like you should be able to check these things yourself, right? But you're like letting this guy do it all for you, and you're not even paying attention.
Okay,
Out
so
of the 2 cells in your body, are any of them brain cells?
no. They have 2 cells between them, 1 cell each. When you combine them, they become 2 cells.
Double-celled organisms. Neither of which are brain cells.
okay, and then at this point it just dies. Okay, so that's it. So I guess we can check all of these should not be squares.
See, the thing is, I expect you to do that actually for the problem anyway, yeah? Like, as juniors, you're meant to, like, actually just literally list out all the values of n.
They struggled to figure out that n equals 13 worked. Like, we gave them n equals 13, and they still
Just
didn't
get n equals
quickly realize that it worked.
But yeah.
Yeah, I feel like, you know, it's like, it's not necessarily
Okay.
about intelligence, it's,
So I think I forgot
but your
oh,
intelligence
wait, no,
is kind of lacking, okay? And the effort is especially lacking, okay?
Yes.
yeah, okay, so that's it.
How did you struggle to realize 50 on...
Alright, thank you, Alex. Very good. The clap is not loud enough.
You did clap louder.
What an ungrateful clap.
Can I just explain my method? If you want me to?
What did you do?
Very different from yours.
Very different.
What did you
Yeah.
do?
Recording stopped.
So, it does not need to be recording. Where do I go? I need a different space. There. So, I'll zoom in a bit. Bit too much. There. So, we have n minus 2 on n plus 5. Now, we can start by assuming n is positive.
Why?
Because then you do positive and negative as separate cases.
Oh.
If n is positive, n cannot be even. Because if n is even, the n plus 5, if n is even, is not divisible by 2, whilst 4n minus 2 is divisible by 2, but is not divisible by 4, and thus can't be a square. So we know n is odd. Therefore we know, because n is odd, both 4n minus 2 and n plus 5 are divisible by 2. Oh no. So we have, that's the equivalent of, so we have 2n minus 1
and we have on. So we can cancel these. And so we get effectively, we have n minus 1 is equal to a square, and both are equal to a square. Wait, how do you know?
How do you know that
you said
both
it's
squares?
divisible by 2.
No, suppose that if it's true that both equal a square, right?
If it's true.
Yeah.
Okay.
If that if the value of n works.
You need to explain when you're separating your cases.
Wait, so loss of generality is good.
Yeah, you need to explain where your logs are.
Log.
So it's divisible by 2 because the first one's clearly divisible by 2, right?
Yeah, but how do you know that's like all of the common factors?
We don't, but
The difference is in that it's incorrect. It's like Alex's solution was correct. This is completely different because it's incorrect.
Okay, wait.
What? Okay, so then what's the case when they're not squares? What happens there?
Then you need to divide by something.
Anyway, let this be a lesson to you. When you're starting out, you need to write the proofs up. This guy didn't need to write the proofs up, but he did it anyway. You see what I'm saying? You needed to write the proofs up, and you didn't. Alright, okay? This is your lesson.
I'll stop presenting stuff in the future.
That's not the conclusion, okay?
The conclusion is I fail when I present stuff. Thus I stop presenting stuff.
No, you failed way before you presented it.
When you solved, quote unquote, solved.
Or I'll stop solving stuff.
Did you think
What?
so?
You need to continue to solve.
Liam, this is not a
No, you two don't get to talk, okay? You're not even at that level of failure yet, okay? You're still preparing to fail, alright? Liam has failed, but he's preparing to succeed, okay?
I'll solve problems and then just not tell anyone ever I solve problems.
No, you never solved the problem, that's the
Yeah,
point.
if I solve problems or think I've solved problems, I just won't mention it to anyone. Because I probably didn't solve it.
What about you just mentioned
Or what
it
about you
once?
just write down a proof?
Yeah, just write it down.
Nah, I just won't mention it to anyone.
Go step by step.
You seriously fix it?
So I was watching this guy who was saying learning is you know that this one of these YouTube people was like business people is like the definition of learning is like same set of circumstances, different behavior. You know? So it's like and then he's like I guess he's stating the converse. It's like, so if you have the same circumstances and the same behavior, then you've learned nothing.
That's contra-positive.
It's like yeah, like
Or what if you're already doing the correct thing?
yeah, exactly. So it's not a correct like his statement isn't correct, but there is something to be taken from it, right?
This is why you need to learn logic.
Yeah, like the logic
You need to learn logic.
is dubious because sometimes you're doing something correct, but you didn't know it was correct, and you were kind of just lucky, or you know what I mean.
Yeah.
So then you
do the same
don't
thing,
change, but you learn, right?
But like you actually know what you're doing.
Yeah, like it's not really the same circumstances, I guess, because it's like in the future. But like
So it's vacuous because it's literally.
yeah, but yeah. So this is the kind of thing, like it's like the most easily avoided part of. I think this is the part that gets people because like people, I think when they can't solve a problem that's too hard, like people accept that differently than when they basically can solve a problem and lose marks on it. You know what I'm saying? That's like a different thing. You know what I'm saying? Yeah. All right. I would like to move on to geometry stuff.
Geometrical.
Recording in progress.
Remember this worksheet?
3 levels.
Yeah. So the thing I want to do on this worksheet now is the other proof of the Symmedian thing.
Why did the stream go black?
Stream go black?
Yep.
Ooh.
Stream. Why did it? Oh, you have to reselect it.
You think it's better to stream on Twitch?
Yeah. I don't know.
Oh, you should do both.
You can do it at the same time?
Yeah.
Ooh. Interesting.
Then it would be hard to keep up with like 2 chats.
Yeah.
There's gonna be no one in the Twitch chat. There's just less people who watch people like you on Twitch than YouTube.
Are there more viewers on Twitch?
No, less. There's less people just using Twitch in general.
What's better about Twitch?
You can do like donations. There's more like some things you can like donate with people from like bits.
Oh, so like you can like monetize instantly kind of thing.
Yeah.
Like you don't.
Also, like if someone subscribes, they pay like I think it's like $6-7 a month.
I mean, I'm pretty
So,
sure
like,
like
more. Like,
YouTube still has donations.
Yeah, the YouTube like less.
But like, it doesn't have like the business.
Ooh.
Yeah. Yeah, it does. Like subscriptions, because on Twitch you actually pay and the creator gets like 60% of it. On YouTube, and then the followers for like
So
normal.
you get more of a cut.
Yeah, so you get more money, but like less people do it, so. Yeah.
Okay, what is this? That's quite interesting.
This is supposed to be another proof of D being the Symmedian of ABC.
Okay, now the medians don't seem as scary because they were synthetically true.
Yeah, they were slain. Alright, Liam, let's go.
I'm too dumb.
Just take your loss and move on to the next one, you know what I'm saying? It's like basketball. If you don't score that one bucket, are you just gonna mope for the rest of the game? Come on. You still got a game to win here.
So what is
I couldn't win N3. How in the world am I going to win this?
That's not true.
No, that's the good logic.
Yeah, but you're stupid. Like, it's not much consolation when a stupid person does.
Look, Liam, if you're gonna say that to them like then, I could say all these things to you too. So just kind of.
You already basically do say those things. You don't hold back very much.
Look, Liam. So what is this diagram?
I think that's parallel, right?
Yeah.
And then
How is
E is
is
like
the
tangent. Tangent.
E is tangent. There's the midpoint right there.
Oh, scheiße. What if it's isosceles? Okay, isosceles trivia. It's all good. So what do you do with this information? You get that those two are similar. But what else? Wait, no, are they similar? No, they're not. I just fake claim it. Oops.
So maybe as like a hint for this proof, it's supposed to do with harmonic stuff.
Oh. I don't see any harmonic impact. It's weird. Maybe I'm just not looking hard enough. Why would it be harmonic?
Wait, does the Symmedian have properties in reference to like harmonic stuff?
Yeah.
What are the properties?
I think we're gonna try to learn that today.
EFCE. Is this supposed to be harmonic?
Yeah, I guess that's like the only 4 points on the line.
This is like, how do you prove harmonic? I think, well, I'll try and record my proof originally for Symmedian to see if I can do stuff. Oh, sure. I need like math. So what did I do? Did like that. Then I did this one. This.
What's it?
And then this is the meter. Okay, so I did. Interesting.
Good recovery time. Let's go. Come on.
And this is the. And I try to show this is the angle bicep. Ah, that's right. I claim this is harmonic.
What you just went through, most people wouldn't be able to survive. Okay, so you did well.
It's like
You don't understand how difficult that is to go through that.
What?
Just someone saying that to you. But you did well. Good stuff.
Someone's saying what to me?
He's already forgotten. Okay,
Oh,
maybe that's
no,
different.
wait. Someone's saying what?
Alright, go on.
No, wait.
this was my original proof, which actually was not very obvious to me. What's that? That's actually not obvious at all. That's like goofy proof. Very strange.
What is the Symmedian harmonic with?
See, what would happen if it was harmonic? What would you guess? Yeah, I guess if you knew it was harmonic, then you'd also know.
this is a
You also
line.
okay. If you know that's harmonic, you also know this is a harmonic quad. You know.
Ooh.
Oh yeah, you do.
I think I see my original proof now. It was, I guess I used harmonic in that one. Pretty interesting.
Symmedian.
Yeah, my original Symmedian proof used harmonic.
So what is the Symmedian harmonic with?
What do you mean by that?
What?
That don't make sense.
Did we prove?
Okay, let me. What is this? How are we supposed to prove a Symmedian? Ring. And also, why did I draw the horizontal line? I need to figure that out.
Yeah.
Maybe they drew a horizontal line to make like BMC, whatever the horizontal line intersect with. That's harmonic.
Yeah.
Yeah.
Oh.
So, you know one thing is harmonic now. But what about the opposite?
Oh, wait.
Wait, do they spin?
Like,
Wait, hold on. What
oh.
do they spin?
Yeah, that makes sense.
What did you realize?
So, like, there's a standard harmonic set. Is like, we call this M.
Oh shit. Wait.
The BMC and the point at infinity. It's harmonic, yeah.
Oh damn.
And that corresponds to this line, and that line, and this line being harmonic. Yeah.
Mm.
I see.
Okay, I'm not so sure anymore. Wait. Okay, now I'm trying to see, like, did they spin the lines and then...
They did something to the line, so I don't know if it's spinning.
Yeah, theoretically, you could spin B to F and M to C.
B to F
Well, at least you should be able to.
and M to C.
Well,
Wait, hold on. Oh, wait, no.
yeah.
No, that's the conclusion.
Yeah.
That's the conclusion.
Yeah.
Okay, I'm gonna spin M to C.
M to C.
Wait, hold on. No. Okay, I need to prove if you spin M to C, then you spin B to no, then you can spin like. Wait, what am I spinning? I don't even know. Damn it. M to speed, then I could see then spin the horizontal line to B or something. Maybe I don't know. Is that it? Okay, that doesn't really make much sense. Because then, like, what if I do when I spin C to E? No, that's not it. That doesn't seem with. It's not
How
quite
does
right.
spinning work?
I don't know. Does spinning mean reflecting?
No, like I'm spinning the lines about it, but I don't think that works. So it's probably something else.
Like, what if you like reflected about the angle bisector?
Oh, good point. Well, if you reflected it, it should. Oh wait, does the horizontal line then turn into the AE? Maybe?
Oh.
Does it?
Oh. Wait.
Ooh. Wait, yeah, it does.
Does it?
Yeah.
It does.
Wait, how do you know?
So horizontal
Apart from that,
line,
it has to.
horizontal line AB equals angle B, which equals CAE.
Horizontal line AB.
Equals the angle at B, which equals CAE by also 6. So therefore, it definitely shows that.
Oh.
Okay, so if we reflect the F,
So this angle is equal to this angle, right?
this angle, yeah, that angle is that angle, which is also that angle.
Yep.
So they're like the same angles. Yeah. No, just vertically opposite from. Vertically opposite.
Okay. The color scheme is bothering me. Alright, what is this angle here? Like here.
Yeah, that one. Now they're equal, so now it's like flipped. But definitely is reflected across the angle bisector.
Oh. Woo!
Okay, but how do you prove it's harmonic? And also, like, what the hell does that mean for the F?
Alright, let's write this down.
If
So
it's harmonic,
that's B,
when you reflect, it stays
C,
harmonic, right?
M, infinity.
Okay, I see.
And all the other
minus.
so if F is the so if BFCE is harmonic,
Yeah.
then F is the
Then F has to be with yeah. Because it's determined.
It's determined, yeah.
Yeah, by the process. Alright. So, how do we prove it's harmonic? You prove it. Prove it.
But prove what's harmonic?
Prove BFC is harmonic and then we're done.
Yeah.
BFCE.
So we see how we now see how BFCE is harmonic implies that F is it's the Symmedian.
F is the Symmedian.
Because B, C, E are determined by the reflection, right? And B, M, C, E is no. B, M, C, and the line is harmonic.
Yeah.
And when you reflect over, B goes to C, C goes to B, M goes to the Symmedian, and the horizontal line goes to E. So if F is harmonic with B, C, and E, then F is the Symmedian.
Yeah.
And then, yeah, okay. You mean like, yeah, FD or whatever.
Yeah, but why is it harmonic? That is the question. I've never seen this diagram before. I'm gonna try to figure out why. Why would it be? I mean, but you can theoretically sine rule chase from that. That's not it. That's not the. Maybe I need to find like some sort of similar triangle. And divide it.
Like, is AD supposed to be like the polar of E?
AD. AD, the polar of E? That's possible. Wait, that's actually potentially. Let's verify this. Wait, yeah, because like AE. Yeah, AE pole is A. And then BC's pole is D. Oh, damn, it works.
What? Where?
Okay.
BC's pole is D.
AE, like the tangent, that's the pole of that is A. And then the BC, which is sexy as well. That pole, the pole of that is D. So then AD is AE intersecting BC.
That's whack.
Whoa, so it's poles and polar.
So this is little a, yeah? And then this is D, right?
Yeah.
So little d and little a intersect at E, which means that the polar of E is AD. Yeah.
Whoa.
Then E equals AD. So is that again a special case of that other theorem?
Yeah, it's like the. Yeah, wait, hold on, I forgot. How do we prove that, like, the. How do we prove it, the pole and polar thing anyway?
I don't know if we did. Like, I think we're kind of relying on this thing being a harmonic.
Oh, yeah, right, we assumed it was harmonic. And then, but this is trying to prove it's harmonic in the first place.
Yeah, and so I want to get to the bottom of all this crap today. Like,
Yeah, we need to stop with the circular reasoning.
Yeah, we just need to get to the bottom of this.
Stop with the circular reasoning. Hey. Bing, bang.
Yeah, so in a sense, if we use our synth proof of the Symmedian thing, right, then all of these harmonic things we got now.
Yeah.
That's good.
Let me try to prove this, the lemma. Very important lemma.
Which lemma?
The pole
Poles.
and polar is from the harmonic.
Oh, okay, so he's referring to, wait, is that the same as saying, like, these DFAs at this point is harmonic?
Yeah, it is. It is.
Yeah.
Except, like, we don't.
We're starting to follow Liam's G notation.
Yeah, I agree. I guess that yields another proof, doesn't it? So it's basically like we can prove D is pole of BC, and then we project onto the circle. So now ABC, the G, that's harmonic. And then and then I can prove it another way that like the Symmedian intersecting the circles.
Oh, really?
I think
Wait, you mean the tangent intersecting the circle or the Symmedian intersecting the circle?
Symmedian intersecting the circle with ABC is that harmonic. I think I can prove that. Yeah.
Okay.
Yeah, so then it's just like reverse frequency. Well, at least like it determines the point.
Yeah.
Three points determine the 4 points. Whoa, another proof made.
Wait, could you? Wait, well, which other proof are you talking about here? So, assuming that.
Okay, well, just like I don't know, this yield. If we prove the lemma, it yields another proof. But I don't know if we can prove the lemma.
The lemma also gives you A, F, G, D is harmonic.
Yeah.
Yeah.
And then you project A, F, G, D onto the circle, and then you get like stuff. You just get if you project it from B, then you get A, C, G, B, and then A, C, G, B is harmonic. There's 3 points. The 3 points ABC determine the 4-point G after we know it's harmonic. We just have to prove that the Symmedian satisfies harmonic, and then I can do that. Wow.
Symmedian satisfies harmonic.
Like, as in, if you draw like a Symmedian,
If you get a harmonic quad.
you get a harmonic form.
Ah.
So like we did that. That's all. It should be. I can prove that though, so that's good.
Oh, how do you prove it? So you're proving if it's a Symmedian, you can get a harmonic quad, yeah.
Yeah.
So like G, B, A, C is a harmonic quad.
The thing is, this still relies on the poles and polars. Yeah. But the poles and polars lemma originally were just like, oh yeah, it's the tangent, and then it's the Symmedian. So it's like still relies on this. So no, can't use that anymore. But did they use poles and polars for this?
You wanna see?
They might not. It's like. Well, okay, they did not use pole. Wait, no, they did use pole and polars. They did use poles and polars. Crap. Yeah.
Oh, E is the pole of AD. Oh my god.
Yeah. Okay.
Literally the same.
So we do have to prove that level. Hey, how you prove poles and polars harmonic level without using this? Yeah, the circuit. Oh wait, no, it's not. Wait, no, it's not. No, it's not easy.
Reflection of AF must pass through
It's
the
not
midpoint.
easy. It's not that easy.
Alright, so then we focus on the pole and polar lemma again. Yeah. Alright, guys, this is time for you to catch up if you obviously didn't listen or tried to get this.
I don't really feel like they
See, this is not the kid. Do you want people to say that to you when you're in this situation? It's very basic. Do not do to others which you do not want done to yourself.
Have I already? I would say that.
It's because you've become desensitized to it now.
Yeah, exactly. I don't really.
Alright, so this is what we're proving, people. So if we got this circle, tangent point here, Yeah. Port of contact. Yeah. And then we take any.
I feel like we should just do poles and polars because this only works if it's on the outside.
Oh.
Like, you can only do the tangent construction.
Oh, so you literally just have pole and polar.
Yeah. Don't prove that that's harmonic.
So we want to prove these 4 points are harmonic, yeah?
Yeah.
Oh wait, so you don't even need the tangents, is that what you're saying?
I'm not like it should still work on the inside. But if you just take any chord, it still intersects at the line, the circle twice, and and there's the point of set. So that should still be harmonic, unless like some weird glitch in the matrix happened in this geometry where like suddenly it's diagrams but then it shouldn't be. It's purely algebraic with cross ratios.
Hmm.
How would I go about doing this?
How?
We're trying to prove that P. What do we call these points? A, D, and E. Yeah.
I feel like we could do this with some projections from the simplest case, but maybe not. I mean, sounds
Simplest
doable.
case.
Wait, I just need to figure out like how do you? This hard. Like I know these 4 points are harmonic by math.
Which 4 points?
I don't know. I just drew like the case where like the line is in the middle.
Oh.
It's like I don't know. I'm trying to think because like that you can use math to prove it's harmonic.
Like this.
Yeah.
Wait.
No, not this.
Not the O. But there is one with O, right?
No, there's no one.
There is another one with O.
Oh wait, if you put it then that's not the infinity. That doesn't really make sense. Confusion. Oh yeah, but that special case still works.
Oops.
We know that's like a common config that is harmonic. What the?
So wait, is the proof? How do you prove this is harmonic? Is it with inversion?
I don't know.
What? Hold on, let's
Wait, no, that one, yeah, that's just in the book.
Yeah.
And then that.
E prime. Oh. Yeah, like actually, there's a pretty cool way. If you already knew inversion preserves cross ratios, then I think you get like Q. It's QR P prime P, right?
Yeah.
That's equal to QR
It's equal to like
P prime,
1
right?
over its.
Right. So if you already knew inversion preserved cross ratios,
Then it has to be like 1 or minus 1.
yeah, it has to be plus or minus 1, right? So that has to be minus 1 because it's external.
Yeah.
But if you didn't know, you could prove it like this as well because you actually have all the lengths.
You do that. Weird. Like, why is it possible to do this kind of? Is this even a valid? What is going on? Why are they concurrent?
Are you trying to prove QD meets AR on E prime D, sorry?
QD.
Yeah, it's like Q. No, I'm trying to prove QA meets RD on Q prime D.
It's RD on P prime E. Oh.
Sounds like a job for passive academics. That's kind of weird. Okay, that's a cool fact. Cool fact.
哎呦，撞我的椅子，
What the?
转的时候撞。
Okay, so how do you do it? Why are they concurrent, bro? This don't make much sense. Maybe we can abuse pose and polars to prove it. Nope, can't do it. I think I'm being retarded.
哎呦，两盘饺子好了。
Oh, lunch.
那底下的可能还有2分钟
Brian.
Recording stopped.
Recording paused. Clear this table.
Yes, sir.
25个饺子，你们一人可以吃5个。就是。
5.
然后那个烤箱的还有几分钟吧。
5 each for everyone of these.
You and the communism has been enacted.
Yeah, so you know how you said that thing about how I learned to not like care when people say the type of thing I said to like Alan, they won't get it.
Oh,
I
yeah.
feel like at some point in life you realize it doesn't matter what other people say. Like if someone says something, it's not going to change anything. It matters that it's actually.
It
The
doesn't
president
matter.
says,
Gotta deal with it.
Exactly. It doesn't like.
It actually matters a great deal.
But also like.
It matters how other people treat you.
True.
But like,
But yeah, like it's out of your control in some sense.
Yeah. Not only and like if someone says something like you will not focus, it's very much in your control whether you focus.
是猪肉韭菜，然后放的橄榄油，所以他们那个过敏肌肉的可以吃吧？哎，不知道里面有没有蛋哦？调馅的有没有放蛋的？
Are you allergic to egg? Are you allergic to egg?
wow.
is this the dogs?
它没有写配料表
On。the chat.
Because there's 3 things. They're like,
Why not?
哦，它放了一些 chicken powder 鸡粉，
Chicken powder.
它还有一点 egg。
Maybe this is the dog.
这就不能吃了。那他吃了没啊？没吃吧？
Yeah. It could be the dogs. I don't know. Cause like you have a bunch of lines. Oh, but that's diagram and it's still. I don't know.
那个好，那个可以吃。
Can you not have
那
potato?
个是什么东西了？
They can't.
对，那个什么
Stop being
派
Russian and not being able to eat potatoes.
That's
Just
so sad.
Yeah.
no. What?
Actually, being Eastern European and not being able to eat potatoes.
那那个
Not being
拿点
able to
之
eat
后啊，
potatoes.
But you can't eat potatoes.
No, you can't.
I can.
If you were Eastern European, especially, and can't eat
If you're
potatoes,
Eastern European and couldn't eat potatoes, you'd eat potatoes anyway.
half of the 90% of dishes are
Except
just
that kind of thing from the salad.
90% of Eastern European dishes are just potatoes.
You can't eat potato. Weak. You're too weak.
这个有什么？是牛肉吗
牛肉啊，beef，
？Beef or fire?
也可以。
Can I get some of these?
你要我念吗？
Thank you. Sir.
You're simply too weak.
But how many each? You said 5, right?
Hold on. Oh. Tomato sauce.
啊，有盘子在那了，5个盘子够你们了。
There's only 4 plates.
1, 2, 3, 4. Where did the 5th one?
为什么少一个？
Oh, let's not have one then.
我放的是5个，怎么少一个？
啊？
嗯
你数的吗？
哦
哎，你不用别按照其他的。
来了来了，
Thank you, sir.
I get
Oh,
some of these.
When will we have exercise break today?
Maybe, I don't know, after lunch. I don't
Mm.
Dude, Jen told me at 2.
Yeah, we'll probably have to go after lunch.
So is she not eating the big piece?
Tomorrow,
Big
big
pizza
pizza
tomorrow.
tomorrow.
Pizza tomorrow.
It's actually quite a logistical nightmare, but
Is it?
we'll do it.
就是可能还在问了，
Have what? Yeah.
也可。不是说有 chicken powder and eggs 吗？
No.
Or is it egg in there?
Yeah.
Little bit.
Weren't you paying attention?
Ah, should be fine. Should be fine.
Father!
You
What?
naughty boy.
哦，还那么多。
Wait, are you sure?
Yeah.
Are you anaphylactic to egg?
No.
Alright.
What is your relationship to egg?
I'm confused now. Are you sure you can eat that?
Is this safe?
我先吃一个，过半个小时再吃一个。
That's not
Whatever
the most
doesn't kill
reassuring
you makes you
response.
stronger.
Smart.
Unfortunately, it's not always
What's
true.
this?
No.
我来煮。
啊？
我自己拿，我要待会儿。
What does getting a stroke make you stronger?
So you're supposed to die from 他不吃是吧？
谁不吃这个？
戴眼镜的小孩，2个不3个都戴眼镜。
Oh,
原来
does that mean I should have more stuff?
Yes.
其实戴眼镜的。
So, if Alarm won't eat that, does that mean I should have more of that?
I'll donate mine to Luke because I know he loves eating extra food.
Alright.
还有 nugget 啊，还有3分钟就出来了。好吃吗？来了。
When you're dying to chew on. You stretch yourself.
But for the Don't worry, I failed that as well. Comment, you have to be better than the person you're saying that to. Otherwise, it comes across much more as like not
Don't worry, you're
positive.
as stupid as me.
Wait, what?
But like,
Yeah.
it's better than me saying I solved it.
Oh yeah,
And that would
like,
be really disastrous for you, Liam.
So you wouldn't have these issues if you were to solve math problems, right?
yeah. Just
Sadly,
solve
I
the
am
problem.
unable to solve maths problems.
You would have known you were able to solve it. Then Liam would feel good about himself.
Still didn't solve it though.
Okay, you feel better about yourself.
Less bad.
Yeah, why do they meet? I don't know. Maybe I need to do more than one transform. Yeah. So I'll have to project it to here. And then it doesn't work. It doesn't quite work. Oh wait. I don't know.
Is that meant for me?
Probably.
Bruh, this shit on my chair.
I didn't realize it was quite hot there.
They're so funny. You want this?
Don't worry. No, you can have that.
I can have that.
You-
I can
I'll
have
just
that.
eat you
I'm a
after you
lid.
eat it. You've already eaten 4 of them.
So I can eat one, I don't care.
It does not matter at this point.
Yeah, good.
It's done.
Oh my god. Why are we do
Wait, did you
What
take it?
is cooking?
What?
What is cooking?
The oven is beeping, sir.
Where some guy died after eating 45 chicken nuggets. And someone else said, so 44 is the
Alonzo is probably like 3.
Oh, I can eat 0. No,
Wait, what?
Wait, how do you die after eating 45? That doesn't sound like that.
no, but they're like this big each. Like,
Right, like 4 chickens.
oh, bro, like 10.
Wait, is there room on the table for this? Or whose laptop is still there?
Oh, that is mine laptop.
Wine at last.
Yeah.
I can't even speak English or
Yeah,
German.
stop speaking German, Liam. I thought you hated German.
Speak one.
Watch, better move this out the way too.
Liam, do you hate German?
You know why I hate Germany?
No.
Do you hate the USA?
Look at younger people calling older people.
Do you hate the USA?
No.
What's with older
But
people
didn't they-
calling young?
One
Yeah,
thing back.
no, but they hated one side in the Civil War, so
Oh,
actually.
you guys are annoying.
I'm getting really sick of
They hated one side in the Civil
I
War.
never trolled people older than me, sir.
I only told
people-
people younger than me.
The same age or
I
younger.
don't think
than me.
Liam trolls.
Yeah, true. I don't troll.
He gets trolled.
Check this.
It's very irritating.
I've never had them. What?
His limit is 44.
Bro.
Bro, you took literally like 3 bites out of it and said, I've eaten my
Sir,
limit. Well, no wonder you said
Alan
that,
is
like,
going to be useless at the
Bruh.
pizza place.
Dude, he's that, no,
You're
You,
right.
you need to learn from the guy who ate 45 chicken
Mm.
nuggets.
and died. So
Liam.
you're
And
44
died.
so-
Like, bro, that guy's limit is 44. You should be able to do better than that.
He died
Yeah, he ate 45 chicken nuggets and died.
Oh, my
Why?
name is 3.
from the chicken nuggets
Yeah.
directly.
Yeah,
Was
like
he already fat?
I don't know, but he ate like a bunch and then just died.
Are you sure it wasn't like he had COVID or something?
No.
If he was fat, Michael would need to be worried about eating 45 chicken nuggets.
Or
Hey, no funny
I'm
people older
joking.
than you.
No, but it's not
Bro, no wonder you're so malnourished. You took
The
3 bites
difference
and then
is-
I've eaten my limit.
I really doubt you have any respect for me. Whilst, like, I'm
I respect you
pretty
very
sure
much,
Michael's aware
Liam.
that I think he is very, very smart. And, like, he is a teacher. And I am aware he is vastly superior to me.
Yeah, you're vastly richer than him.
Actually, Michael's not a teacher. Michael's a
Oh.
cult leader.
Wait, no, that doesn't.
Liam is vastly wealthier than you.
Wealthier. That's so funny.
I'm not like you make me out to be. If someone heard how much you said I was rich,
But you
I
are.
would be some $10 million or something, or some
You are.
ridiculous amount of money.
I mean, your parents probably or getting close,
No, they don't.
But I don't see how this is like something worthy of being teased about, though. How is this a bad thing?
Yeah.
I don't
It's
know.
a bad thing,
Yeah,
Liam.
Liam, how's it a bad thing?
It's not bad. It's a good thing.
Like, being richer is strictly better than being poorer.
Exactly.
Yeah.
Yes, so why are you complaining?
There is no nobility in poverty. Just poverty.
It's just boring. Yeah.
Wait, are you claiming that RD and QA be on the line?
Mm-hmm.
Yeah, but I don't know if that works.
Like, does it actually mean on the line?
You should.
It should, huh?
Mm.
Liam, how much do you pay to take a hot bath in some springs?
I don't want to take a hot bath in some springs. That
What
what?
some rich people do.
What the hell? Be quiet.
I mean, it's not really. But people here are paying 14K
For how many minutes?
for a hot bath in some lava, you know?
Oh my days.
They have nothing that they're like better than me, or any ground to actually make fun of me on. But somehow they still want to. No. I can use you as something to bicep curl. Like, what? Like, literally! I can bicep curl instead. What?
Yeah.
I'm like, we're gonna get more pie.
Yeah.
Was I that annoying when I was in
Yeah.
year 8?
Yeah.
That's disappointing.
Are you still? Is he still that annoying?
No, he's more than
Or more or less?
Alright, focus on the maths, okay?
or a moderator.
What?
Literally, every time you're on your phone and we look at it, you're always on Quora.
What's wrong with Quora?
Nothing, but what's wrong is when you like spend 15 hours a day on it.
I don't spend 15 hours a day.
My bad, Corty.
Right. You spend 15 hours a day probably on Roblox.
Actually, only 12.
Yo, what are you looking for, Liam?
Drink.
There's water.
I never knew.
Well, now you know.
There was even water in the fridge, I think.
Oh, put it in the fridge? That's a vast improvement.
Oh, you
That's
could have.
not the
You were right there.
Oh yeah, I'll grab water, put it in the fridge, and then grab water from the fridge.
Yeah.
Yeah.
I'm gonna put that in the bin.
Hey, I'll put 2 waters in the fridge. And grab 1 water from the
Cheeseburger.
fridge.
Or should I chug another bowl?
I really hope there's water in the fridge now.
Hey, probably
If
should
there isn't, there will be.
2 bottles.
There appears to be one in the fridge. As long as the neighbour right. What in the fridge is chilled?
There's
No
definitely
way.
some Brockhard-esque things going on here.
Broccoli.
Like this and P are like the
Cola.
Brockhard.
What's that water bottle in the cracks?
The circle continues.
Are you on Quora again?
No, I'm not on Quora.
He's on.
Or then who are you messaging?
I'm not relevant. It's not relevant who I'm messaging.
Charlotte?
Probably.
I think it is.
That's better than 4.
Yeah, exactly.
Oh, okay, so
I
you're
doubt you two have ever talked to a girl in your life.
Actually, I have.
Same.
We're probably issuing you a restraining order.
How did you know?
Once again.
It's like she's the police officer, actually.
Once again, Liam gets it.
Once again, Liam is a calculator.
Oh, you guys are so annoying.
Yeah, but only half the time was a restraining order.
Liam, do you think I can chug this?
Sure. Wish I could issue.
Okay, so I guess if worst case scenario, we have the Symmedian thing, then
we prove this.
then we prove the prove the things are harmonic, yeah. And then we got a whole bunch of other things that are harmonic.
But the thing is, we use like they use this in Brockhard, so we can't use Brockhard.
Oh, I mean like, so I guess the logic for us would go like this. Prove the Symmedian is the tangent thing directly, yeah? And then use this proof of the Symmedian thing to conclude that all these things are harmonic. Yeah. And then it also implies that it's a harmonic quad as well, right? Yeah. And it also implies the lemma, doesn't it? Right? And then we use the lemma to prove Brockhart's. Yeah. That's how like the logic works right now.
Whoever wrote this was able to prove this without using Symmedian.
Yeah, but they had the lemma, yes. They had that pole and polar lemma. I guess this is what we're trying to prove, yeah.
That's pretty weird, like.
Wait, I do seem to remember like something like this. There is some kind of projection.
How to get it? happens now?
What did you do?
I converted this display into.
Now we can't say anything.
I just watched the stream video. Now I can see.
Actually, I didn't need this display here. I'll just undo it. I think I had originally. This is on the zoom. That's the. I can put the zoom on the other screen, but
When will we do exercise play?
soon.
It's a very difficult to prove lens. You don't know how to do it.
I'm curious to see how it's proved in EGMO.
EGMO by Evan Chen.
Yeah.
Yes. Don't touch it.
So 169.
Neither of you touch my pencil case. Like 3-year-olds, you know that?
Wait, broadcast theorem is not proved here, right?
What did they say? They said it's self-polar.
Oh, the proof here.
The idea is it looks a lot like. Okay, they did that.
Lemma 9.11.
Ah shit, they did the same thing. Using the lemma.
You need lemon 9.11, sir.
Alright. Well, we look at 9.11.
Yeah, I think last time we must have proved it with Pascal's. Here's the Apollonia circle.
This is basically just more lemmas in Olympiad geometry.
Oh!
That's pretty interesting.
Yeah, so we got the 7 Menelaus thing. Ooh.
That's pretty interesting. Menelaus. Oh, that's pretty cool. And that's a complete quad right there.
Yeah.
Wait, what's the difference between harmonic and harmonic bundle?
I don't think there really is a difference.
Does a harmonic bundle just mean it's harmonic?
Like a harmonic is like an adjective, yeah?
The actual thing is a harmonic bundle.
Well, it could be a harmonic set, but then... But it's weird to end with an adjective, don't you think?
Yeah.
I think this is interesting.
That's some good water.
Harmonic quadrilaterals, harmonic bundles. Alright, sorry, I'm just kind of scrolling a bit. Okay, so this is just defining the basic cross ratio stuff. Yeah, we already have that. And then given points, midpoint. Harmonic quadrilaterals.
They use Symmedians there.
Symmedian. Stuff. Okay. We obtained this from Lemma. Oh yeah, that's how I did it.
AXBY is harmonic. Yeah, okay, so we got the inversion part. So now this Symmedian thing is good, right? You know how the Symmedian thing works, right? Do you, Slava? Alarmed? So basically you got like, you know what Menelaus' theorem and Sever's theorem are? Were you asleep when we were doing that?
Bruh. Do you know what they are?
The
man
both of them
died.
don't.
The fam points right here. Yeah, so you have a triangle, right? ABC, yeah? Basically the idea is you got a concurrency point at P, right? Which means like it has to satisfy Sever's theorem, yeah? Liam, you tuning out here.
Oh, sorry.
Do you understand it has to satisfy Sever's theorem?
Yeah. I know.
Okay, so then if you take the points where it touches E and F and you join it to X, right?
Yeah.
Then E, F, and X have to satisfy Menelaus' theorem.
Yeah.
Right? But Sever's and Menelaus are basically the same theorem.
They're joules of each other, right? Or like.
Well, the formula is the same, right?
Yeah.
It's just it's -1 for the X, +1 for the D, right? Which means that this is harmonic because they're in the same ratio, yeah?
Yeah.
Yeah. Yeah, actually, this is the really the main. So projective geometry, a lot of it is defined around complete quads. So the idea is for every complete quad, it's like every 4 points is basically harmonic. Yeah.
That's crazy, bro. Oh damn. Literally everything's on.
Yeah. So if you start with XB, DG, DC, look project it to all the other sets of 4 points. You know what I'm saying? Like for example, like if you label this one, right? Then you can project. Let's see, what can you do? Is it through A?
A.
And you get that's harmonic, yeah? Yeah, literally any set of 4 points on this diagram. How does that relate to us? So maybe that is a nicer proof of Brocard's. Wait, if we prove Brocard's, we also get the lemma, right? Or
Wait. Let me see. You get the lemma.
from Brocard's.
What? Let me see this.
Actually, it was on that cross ratios worksheet as well. Where is that cross ratios worksheet? Wait, do you want to first see how to do Brocard's with the lemma?
Yeah.
Oh wait, is this the proposition? This is it, right? Yeah.
What is going
Recording in progress.
Yeah, so let AB be a chord of a circle. And then you draw these things. Yeah? That's the lemma we're looking for, isn't it?
Yeah.
So we only consider the case where
Hell
P is
no, they
outside.
constructed the tangents. No. This is diagram dependent.
X, Y. Oh, they're only doing the outside case.
You are scamming. Okay, I think you can get the inside case.
Well, I mean, at least he's saying it's considering the out guys. It's not like unaware of diagram dependence.
I think you get the inside from the outside.
X, Y intersect AB. Oh, okay.
Lemma 9.9 gives this. What's lemma 9.9?
Lemma
keeps-
9.9.
I think you can click on it, sir.
Yeah, but you have to not. Ah, crap. You didn't put
You have
the
to
link.
find lemma 9.9.
Oh, you don't have to. You can kind of guess what it is, I guess. Yeah, lemma 9.9. This is kind of like what we were saying, right?
Symmedians, which means that we can't do it. Ah,
So that's the logic we had in mind, right? So far, that's like our
Damn.
backup.
yeah.
That's the
It's like proof Symmedian first and then.
yeah.
Bro, they scamming.
So is there a better way?
They have scamming us.
Yeah, I think to appeal to like a sense of elegance, there should be a purely like projective way to prove it. Hey, you know what I mean? Or like
This is a scam.
Then Brocard's theorem. So in that diagram, the complete quad. Oh well, then it completely makes sense that like, so like this is harmonic, right? Yeah.
So then, does that imply? Implies that
It's like the polar of something, right?
It appears on the polar.
R is on the polar of P.
Like appears on the polar. I would take the outside case, but he didn't prove the outside brutal. But did he? It appears on the polar of R.
Oh,
P is on the
P is on
polar.
the polar of R, and Q is on the polar of R, right?
Oh, done.
Yeah.
Yeah.
Okay, so that's nice. You get that?
Wait, can you repeat it once more? I've been concentrating so... I haven't been on my phone or doing anything.
You don't get to use that entitled voice.
They're not quiet.
So like, we have
Wait,
this is a
it
complete
the
quad,
sixth
right?
Oh, yeah.
Oh crap! No,
I'm
this
saying like
isn't-
every 4 points is a complete quad is harmonic, yeah?
yeah, but it's not exactly because when we're intersecting on the sides of the corral, not the circle. I think I ran into this. But I think
Oh,
if you
yeah.
can. Oh no, wait. You can fix this. You can fix.
How to fix?
Yeah, for.
Well, I mean, it works for these 4 points, right?
Yeah.
So like, the point is, if you have these points harmonic, right? Yeah.
Yeah.
Then
So Q is on the polar.
then this must be the polar of Q.
Oh.
Yeah.
Oh.
And that's what we did last time.
Yeah.
Oh. And... Oh.
So like intersect circle. It's like a secant with
Yeah.
the intersecting. Yeah. That's pretty nice, right?
Yeah, and then that basically gives you it.
Yeah, I think this is a good way to conceptualize. So we're just missing kind of like one thing. One thing, and we can be happy.
What is this one?
We just need to chase this one thing. What is this one thing? Oh, we can try to consolidate this again on Tuesday or something. I don't know. Yeah, this one thing is that lemma. See if that lemma can be just proved outright, yeah?
Yeah. Can you just prove the lemma, bro? Oh god, this lemma is very annoying. I don't know how to do this.
Yeah, we just used that lemma to prove Brockhart, didn't we?
Yeah.
That's what we just did, right?
Yeah.
Okay. And we can prove the lemma using the Symmedian synth proof, yeah? But it's slightly unsatisfying because... Well, yeah, I guess the harmonic has to come from somewhere. Like, it can't just be vacuous, but...
Yeah.
Still... It just goes to show how circular our understanding of some of these things were.
Yeah. Very
Cross.
sus.
Yeah, here, this is the cross worksheet. Another MIT wonder.
The cross ratio, what the?
Okay, so...
When you cross ratio.
Yeah, this is the quadrilateral theorem. So maybe should it only depend on this complete quad thing?
Probably.
Okay, remember we went through all the Desargues, Pascals. The only thing missing is that lemma, but is it gonna be here? That's the thing. Or maybe they prove it as Pascals or something. Or maybe it's just not here.
Yeah.
It's not seem to be.
What? Conic butt.
Proof 1 using tangents.
Yeah, this is I think what I remember. Yeah, this is particularly good, right?
Oh,
Yeah,
damn.
that's the one we're looking for.
Damn.
That's
Yeah.
the one. Pure cross ratio chasing.
Oh, damn. Wait, you can just swap. Oh.
Victory. Flawless victory.
Okay, that is. It's basically like very indirect.
Alright, so this is even for a conic, not a circle. You see this?
Yep.
So you take PQXY, yeah? And you project it to this line,
Yeah.
the tangent line
What,
to
you
U,
swap?
and then you go to Y, and then you go to X, right?
Hmm.
And then you go to this line, yeah?
Yeah.
Okay. So that'll give you the the cross ratio of the quad basically. Yeah.
Yeah.
Okay. And then you do the same with V. Okay. Yeah.
Yeah.
You get to the cross ratio of the quad. Yeah.
Hmm.
And I guess the difference is now V and U are swapped or something. Like P and Q are swapped. Yeah.
Yeah.
So the P corresponds to U before. Now P corresponds to V. Right.
Yeah.
But otherwise it's the same. Yeah. So then you get cross ratio PQXY equals cross ratio QPXY.
Ooh.
Bam.
Damn, bro.
Damn.
That's what we
Okay.
wanted.
Okay. This is like the 1 or -1 technique.
Yeah. See that's the classic because like the elegance, right? You got to preserve the elegance.
Yeah.
Yeah.
That's when the theorem.
Like you want everything to be projected.
Yeah, like that's the difference between theorem building and theory building and problem solving. Yeah. Like the problem is solved once you get the answer, you know.
Mm.
But the theory is built once it's like,
Elegant.
yeah, it's a shining beacon of light to all the
They got
barbarians
proof
in the
2
darkness.
as well. They got proof 2.
What was that?
Did you hear what Michael said? Barbarians in the darkness.
Yeah, that's a great proof. I don't know why we didn't get up to that.
Wait, that's like beautiful.
No.
You just swapped the cross ratio chase.
Yeah, I think we appreciate that even more because like it's not that easy to come up with.
But that's actually clean as hell. I don't
Yeah.
know why I didn't think of that because I kind of glossed over that possibility.
I think it might be easy to actually just not actually swap Q and P. Like it might just like I don't know. Like if you don't do it carefully, it just looks like PQ equals PQ.
Yeah, like I tried projecting onto a circle, but I didn't think like it would actually work. I thought, oh, I just did nothing. It does something.
Yeah. All right, exercise break time.
Recording stopped.
How are we going to?
Basketball? You want to go to basketball?
Yeah.
It's not gonna rain, right?
You have to end the
Is it
stream.
dramatically? Is music?
I don't want to end the stream, but I think I have to. I don't know. Should I end the stream?
Yes, sir. Due respect.
And the question is, do I put the physics on the stream? It's gonna be pretty.
So what's the
I feel like I'm going to be tempted during the physics to just start doing Otis.
Hmm. I mean, there's still maths there. That's why I'm like presenting it here. A lot of
He's only doing
calculus.
the math part of physics.
You know what? The physics is like so scuffed. It's like all the examples, like the randomest real life examples.
Yeah, the thing is, like, in physics, like, people doing physics, they don't know the difference between a proof and a claim.
Yeah, exactly. Like that center of mass thing. Like that's been like unproved in my mind for like all of eternity, and it's probably like
Yeah. I'm like, is it even... I don't know if my counter example is legit, but I'm pretty sure it doesn't make sense for something of degree 1 to work with something of degree 2. So,
yeah, it's kind of annoying to end a stream when there's actual viewers. I'm sorry.
Damn.